Good morning, welcome to new lecture. Today I will talk about truss. What is the truss? Let's define truss. A truss is a structure consists of all straight members. So the member of truss should be straight member. Connected together with pin or hinge joints. So at connection of the truss we don't have any internal moment because they are pin and hinge and there is no reaction against the bending moment. Connected only at the ends of the members. All external loads must be applied only at the joints. So, truss is a structure, includes straight members. All members we connect using pin or hinge, and the members they are straight, and only we apply external load at joint. And the structure, in order to have a stable structure, should include several triangles. For example, if I have 4 straight members and using pin or hinge I connect these straight members together and I attach to the ground using one hinge support, another roller support. This structure externally it is stable, it cannot move in the X direction, Y direction or Z direction. So support, connect this structure to the ground in the stable way, or it is at equilibrium, but internally it is unstable. Because if you apply very small load, lateral load, it is clear this rectangular shape or square shape will deform like one parallelogram and it will fall down. So it is not a stable structure. But if I add one more member, if I add one more inclined member or diagonal member like this, now any force in any direction I apply in this direction or in this direction or in this direction, this structure will be at equilibrium and it will be a stable structure. So this kind of structure we call it truss, and it is simple truss because you see you have one triangle, two triangle, and first triangle is here, second one, and if you wanna expand this truss you can add to another straight member and attach together using another pin. And if you want to expand more, again 2 more members, one another pin, and so on. So you can develop this structure, you can make it bigger, and always it will be stable structure. This kind of structure we call it simple truss. In order to design simple truss, we need to find internal forces in these members. Because in order to design any member, we should know internal forces. We should know for which internal force we are designing that member. So if we have one simple truss, the simplest truss should include 3 members, and using one pin support, another roller, I attach to the ground and subject it to external load, for example, P pound, and member length, this is L, for example, this is L. In that case, this angle will be 45 degrees, and this will be square root of 2L. So this will be the simplest truss we have. If I apply, for example, P here, I should be able to find internal forces in these members. If I find internal forces, I can design any member for that internal force. I can design, for example, any kind of wood member or steel member or concrete member in order to withstand against that internal force, and we will not have failure. So first step, we should be able to find internal forces in these truss members. Truss members always should be straight, and both ends you see should be pin. And we should apply only external load at the joint. Any joint you can apply, but you cannot apply load on the member like this. You should apply force at the joint. In order to find internal forces in truss member, in the effect of this external load, first step, we will assume the truss member weight it is small, so we will neglect the effect of self-weight. So we will assume these are weightless. First step, we will find reactions. Here reaction, this should be P, this will be P up, this will be P down. If you cannot find like me very fast, you should write equilibrium equation. If this is, for example, point A, this is point B, AX plus P is equal to 0, AX will be equal to negative P, it means AX will be P in inverse direction. Or if I want to find, for example, BY, I can take moment respect to A, so BY times L minus P times L is equal to 0. From here, BY will be equal to P, and it is upward. If I want to find AY, summation of forces in vertical direction equal to 0, so AY plus BY is equal to 0. Because BY was equal to P, from here if I plug instead of BY P, I can find AY is equal to negative P. Negative P means it is P in inverse direction, downward instead of upward. After I find reactions, I should start from a joint. We have 2 members attached to that joint, or we have 2 unknowns. Because if I cut the joint and I show a free body diagram, for each free body diagram I can write 2 equilibrium equations for 2D plane structure. If our structure it is in 2D plane or it is in plane structure, if I cut one joint, for example joint A, P, P, if I cut it like this, in each joint I can write 2 equilibrium equations. One equilibrium of force in the x direction, another equilibrium of forces in vertical direction or y direction. With 2 equilibrium equations, in each cut I can find only 2 unknowns. So I should start from a joint. I have only 2 unknowns, 2 internal force of the member which they are unknown. I don't know that. If I start from joint, it has 3, 4, 5 unknowns. So I can write only 2 equilibrium equations and I will not able to find internal forces. But for 3D truss, if it is in 3D space, I can write, if I cut a joint and show free body diagram, for each joint I can write 3 equilibrium equations. Equilibrium of force in the x direction equal to 0, equilibrium of force in the y direction is equal to 0, and equilibrium of forces in the z direction is equal to 0. Here, for example, ABC, I can cut from any joint because 2 members, unknown force, 2 members. Assume I start from joint C. This is external load P. Internal forces, they are unknown. Internal force always, first, once you are cutting the joint and showing the free body diagram, the arrow direction should go out of the joint like this. This means, remember, it is in tension. If you, with this assumption, you solve it and find negative answer, means initial assumption it is not right, and that member is subjected to compression. So this is tension direction, arrow direction, you see, it is going out of joint C, so it means tension. This angle, it is 45 degrees. So summation of forces in horizontal direction and vertical direction, I will write for this joint. This member force FCB, this member force, it is FCA, both they are unknown. Summation of forces in horizontal direction, FCB sine 45 plus P is equal to 0. From here you can find FCB is equal to negative P divided by sine 45. Now, summation of forces in vertical direction is equal to 0. FCA plus FCB cosine 45 is equal to 0. Because you have FCB, you will plug here, you can find FCA. So you find this member force and this member force. Then you can move to this joint and find in similar way the member AB force. Pay attention. FCB, it is negative, means compression. Initially I assume it is in tension, but you end up with negative, means it is compression. And if you plug negative here, FCA will be positive. It means it is in tension. Of course, initially you can guess to see it is in tension or compression. In some complex truss, it will be difficult. Maybe you will have mistake or error. But in simple cases like this, from beginning you can understand this member, it is in compression or tension. For example, member CB. I want to see it is in tension or compression. The easiest way in order to visualize that, remove the member CB. Remove the member CB. If you remove the member CB, what will happen? This member AC will rotate respect to A and it will move down like this. So the distance from C to B will decrease. So the distance from C to B will decrease. That means the member CB, it is subjected to compression force. Or if you want to see, for example, member AC, it is in tension or compression, remove that member. If you remove that member, this structure will be unstable, and if you apply load P from left to right, this CB will rotate respect to B and it will move like this. So the distance from A to C, it will increase. That means that member, it is subjected to tension. So this is easy way to see it is in compression or in tension. But my Advice to you as a beginner, always cut the joint, show forces in the tension direction, go out of the joint and write equilibrium equation, and you will see it is in tension or compression. Then double check with the way I told you, remove that member, see those joints. If they come close to each other, that member it is in compression. If they go far from each other, it means it is in tension. Let's I explain one more thing. Compression, remember it is subjected to compression. That internal force will be negative. If member it is subjected to tension, that internal force will be positive. The way now I solve the previous example, I cut joint and I start from the joint, we have two unknowns, and I move from that joint to another joint. That way, in order to find internal forces in truss members, we call it joint methods, because I'm cutting joint by joint. There are two ways in order to find internal forces. One of them it is joint method, which is really easy. You will cut joint by joint and you will find all internal forces. I will explain that this session. Next session I will explain you another method which is faster, and we call that section method. So let's look at the joint method today. Next example, numerical example, and I will solve with number. Assume we have simple truss, something like this. A, B, from here to here it is 5 feet, 10 feet, 10 feet, A, B, C, D. I call this angle alpha, this angle beta. So I have one simple truss. You see A, B, C, D, two triangle, and it is stable. This truss is subjected to two concentrated load at joint C and D. So one of them, it is this force, 10 kips. Another one at this joint, again 10 kips. I want to find internal forces in these members. First step, let's find alpha and beta. Angle alpha will be equal to tangent inverse of 5 over 20. That will be equal to 14 degrees roughly. Alpha, tangent alpha is equal to 5 over 20. So alpha will be equal to 14 degrees, I'm writing here. Beta will be equal to beta inverse tangent of 5 over 10. That will be 26.5 degrees. Tangent beta in this triangle will be equal to 5 divided by 10. That will be roughly 26.5 degrees. After I found alpha and beta, let's find reactions. Here, this reaction in the vertical direction, it is 0 because this is roller. This reaction, AY, summation of forces in vertical direction is equal to 0. AY minus 10 is equal to 0. So AY will be 20 kips. AX, if I assume in this direction, I can write summation of moment respect to point B. So AY times 5 minus 10 times 10 minus 10 times 20 is equal to 0. I'm taking moment respect to point B, AY times 5, counterclockwise positive, minus 10 times 10, clockwise negative, minus 10 times 20 respect to point B, and that is clockwise, and again it is negative, equal to 0. From here I can find AY. AY will be equal to, let's see, AY will be equal to 60 kips. So it will be 60 kips from right to left, because summation of forces in horizontal direction should be equal to 0. So Bx minus Ax is equal to 0. So Bx will be 60 kips in inverse direction. So 20 upward, 60 from right to left, 60 from left to right. These are reactions. Then I can cut from any joint. I have two unknowns. For example, I'm cutting joint B and I'm showing free body diagram for joint B. This will be 60, this will be F, BC, and this will be F, BA. Summation of forces in vertical direction equal to 0. It means F BA is equal to 0 because there is no any other external force in vertical direction. Summation of forces in horizontal direction equal to 0. So FBC plus 60 is equal to 0. From there, FBC will be equal to negative 60. So BA, it is 0. BC will be negative 60. Negative 60 means it is in compression, and you can understand that. If you remove member BC, this triangle will rotate respect to A, and this triangle will rotate. You see these forces, they are downward. It will rotate clockwise. So the distance between B and C will decrease. So it is under compression. After joint B, I can cut joint D. If I cut joint D, this is joint D, this will be FDC, this will be FDA, this will be alpha. And here I have external force 10 kips. Summation of forces in vertical direction is equal to 0. It means FDA sine alpha minus 10 is equal to 0. Summation of forces in horizontal direction is equal to 0. It means FDA cosine alpha plus FDC is equal to 0. From here you can find FDA, you will plug here, you will find FDC. So FDA finally will be equal to 41.2 kips, and FDC will be equal to negative 40 kips. So DC negative 40 kips, DA it is positive 41.2 kips. And again, for example, FDA, I want to see, I want to investigate to see AB, it is under tension or compression. Remove that. If you remove it, for member CD, if you pull down point D, the distance between A and D will increase, so it is tension. So after I found those, I can move to the next joint. Next one, joint B. So here I have FCB, which I found it is negative 60. Here I have FCD, I found it is negative 40. CA. This angle is beta, and here I have 10 kips. Summation of forces in vertical direction equal to 0. It means FCA sine beta minus 10 is equal to 0. You have beta, you will plug here, you will find FCA is equal to 22.36 kips, and it is positive. So it will be positive 22.36 kips. Again, if you remove this member, you pull down point C, the distance between A and C will increase, so this is under tension. The way I cut joint by joint, and I started from the joint, I have only 2 members attached, we call it joint method. So I will assign you several homework problems, you will practice, you will learn better. Later on I will explain section method. In joint method I should start from a joint. I have only 2 unknowns and I move to the next joint. In some big truss that will take long time. Sometimes we are interested in to find only one member force. So in that case there is no reason I move from the first joint go to the until the end. It will take a long time. So section method give the answer faster. If I am interested only 1, 2, 3 member forces, there is no point I find internal force for all members. In that case I will use section method, which I explain later. For today let's explain one more thing. Some members you see here, member for example AB, there is no internal force. Internal force it is 0. Those members we call it zero force member or zero member. Zero force members in truss means under these loads they have no contribution. Internal force is equal to 0. Now you can ask, if there is no force, if there is no contribution, why we are adding that member? Those members we need it, we cannot remove that. First, if we remove it, we will lose the triangle shape of the structure. Triangle shape will give our structure stability. In that case, our structure will be unstable. And pay attention, we neglect the self-weight of the members. In reality, in real life, we have self-weight for each member. So this zero member, zero force member, will have contribution and it will sustain against the weight of, for example here, part of weight of member BC. On the other hand, in the real life, you cannot have only fixed external load. For example, you build this truss, it is subjected to the wind load, earthquake load, or different load during the lifespan. So maybe today our external load is like this, tomorrow we will have another load here too. So we need those members for having a stable structure in order to sustain under self-weight, and in future maybe our external load will be different. But there are a way, and it is a trick, you can recognize those zero members very fast. Let's see how we can recognize those. So if I want to define, let's say first define zero force member is a member in a truss which given a specific load at rest. It means neither in tension nor in compression. So internal force for that member under those loads we apply at nodes and we neglect the self weight, it is equal to the 0. How we can recognize those members? Pay attention to this trick and apply to all examples. If you have a joint with two members, only two members attached to one joint, and there is no external load at this joint and there is no any support at this joint. So you have a joint pin, two members attached to this joint, and those two members, they are not collinear members. You see, they are not in the same direction, and there is no external load at joint or any support. In that case, both these members, they become zero force member. Internal force in those members, it is equal to 0. If you have a joint with three members, and two members, they are collinear. They lay in a straight line, they are in the same direction. But there is no external load at the joint. The third member becomes zero force member. There is no internal force in the third member. Internal force in the third member is equal to 0. If you have a joint with four members, for example, member 1, 2, 3, 4, and 2 by 2, they are collinear. 2 by 2, they are in one straight line, and there is no external load at the joint. In that case, the internal force for these members, 2 by 2, they are equal. For example, F1 is equal to F2, F3 is equal to F4. If you have a joint with three members, two members, they are collinear. Two members, they are in one straight line or in a straight direction. And the third member, it is in direction of one external load, for example, like P. The internal force for this member is equal to this external load. So the internal force here, it is equal to P. Pay attention to these points. Now let's look at several examples. First example, look at this truss. You have force here, 500 pound, another force here, for example, 1000 pound. And the member length, for example, it is L or something like that. Member 1, 2, 3, 4, 5, 6, 7, 8, 9. Here, 9, 10, 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here, which member? They are zero force member. Okay, let's look at the joint one by one. This joint, two members, but we have support, so we cannot tell. This member, 1, 2, 3, 4. 4 members, we cannot tell. This joint, 1, 2, 3 members. 2 members, they are in one straight line, they are collinear. A third member, it is perpendicular to that, and there is no external load at this joint, so this one, it is 0 force member. Let's move to this joint, 1, 2, 3. 2 of them, they are in one straight line, so laying in the same straight line means they are collinear. This member, it is in perpendicular direction, there is no external load at the joint. This is 0 force member. Now, so member 3, member 9, let's look at this member. This member, this joint, we have 1, 2, 3, 4, we cannot tell anything. This joint, 1, 2, 3, 4, 5, we cannot tell anything. This joint, 1, 2, but we have a support, we cannot tell. Here, this one, 1, 2, 3. If we didn't have this 500 pound member 6 internal force, it was 0. But now we have this 500. So internal force will be equal to 500 pound. Let's look at the next example. £1,000, 500 pound member 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Let's look at here. Which member? Here, the first joint, 2 members, there is no external load here, there is no support. Both of them 0 members. Both of them 0 members. Here 3 members, okay, 2 of them collinear, another comes to that joint and there is no external load. This is 0. If this is 0, this 3, 1, it is again 0 and perpendicular. So now the number 4 will be equal to number 2. So this is equal to 0 as well. Because you see, number 1 and 2, both they are 0. If you remove those, even, here, both of them comes to the joint, there is no external load, both 0. So, let's move to next one. So, the member 1 is 0, member 2 is 0, member 3, 4, 0. This joint, 2 of them collinear, there is no external load, this is 0. So, 9 is 0. So let's look at 1, 2, 3, 4, 9. Here in this joint we cannot tell, here we cannot tell anything. Here in this joint, both of them collinear. If we didn't have this 500, member 6, it was 0 force member, but now internal force it is 500. Other we cannot tell from the beginning. So this is the way we will differentiate 0 force member in simple trusses. Thank you so much for watching this lecture. See you next session. Bye bye.